Hello, in this video we're going to be talking about when things don't go perfectly right in meiosis. In other words, errors occur. So let's not waste any of your time. Let's get right to it. Now when we're thinking about errors in meiosis, we know that in just regular DNA replication, there are a lot of things that go on to make sure that that goes through perfectly, that the right nucleotides are matched up and those base pairs. And we know that through the cell cycle, there's a lot of steps, a lot of checkpoints that are instilled with the idea of making sure that everything is going perfectly right. And we know that from our the cell cycle video series that when things aren't, and if it's just really a bad situation, that the cell can even just be terminated and just go from there. But so we know from a chromosome standpoint, a lot of things are in place to make sure everything goes right. But we know mutations can occur in those situations. But we're not talking about any of that. What we're talking about, errors in meiosis, is when just things do not divide, don't separate. I mean, you can have situations where non-disjunction occurs, to where the chromosomes don't separate properly. In other words, you can get, if you've got two homologous chromosomes, in other words, you have 4 sister chromatids, you can have the situation to where 3 of them are pulled to one end in whatever way that can happen, and 1 to the other, which is a very detrimental situation. You wouldn't think that just something happening at one of the chromosomes could cause much, but we're going to look at a lot of conditions where just from that standpoint. You can also have a situation where chromosomes are missing or extra chromosomes, and you can even envision that at those chiasmatas that maybe you can even tear off portions. Something could happen in those, and in a lot of cases, just like with when the cell decides, hey, this is not going well, we just got to shut this down. The body can also say, hey, something's really wrong with that zygote cell. Something is pretty bad, and we just need to terminate it. Unfortunately, I mean, it's a horrible situation to go through. But these two situations, non-disjunction, aneuploid gametes, that's one of the major causes of. Now, when we say spontaneous abortions, we're not talking about. Well, I shouldn't put my own thoughts in it. We'll just leave it at that. But we are going to look at some examples of each of these. And you can see in the diagram. Beside me, the one at the top, the far left, that's a normal meiosis division, and you can see we end at the bottom with 4 cells with equal and the same chromosomes. But then in the middle, if meiosis 1 doesn't separate properly, what you can have, and that's when you end up having one of the 2 sets with 3 or just say extra. And then of course, if in the diagram on the far right, that's if meiosis 1 separates properly, but meiosis 2 does not. And then you can see that you have 3 or 2 of them that are where they should be, and 1 that has too many, 1 that doesn't have enough. So the take home there is, if the error is in meiosis 1, then you're going to have half of them that have too many and half that don't have enough. If the error occurs in meiosis 2, then you have half are okay, they're the way they should be, and that the other half, one half of those, or a quarter, are too many, and a quarter have too few. An example of aneuploid gametes is when, like at one of the sites, and this is now this one is in chromosome 21 or trisomy 21. It has 3, okay, and that's where Down syndrome can occur at that point in time. This slide here is just kind of a reference point to some of the conditions. I mentioned trisomy 21, which can cause Down syndrome, but there are others. You could have Pauto syndrome, if I'm saying that right, Edwards syndrome, Turner syndrome, and these are all from various chromosomes not separating properly, whether it's number 3 or 13, 18, and I mentioned 21. And so there's lots of conditions that just from simply at one chromosome not separating properly. And the same with non-disjunction. You can get Turner syndrome, Klinefelter syndrome, those kind of things. So it's if it doesn't properly separate, you wouldn't think it'd be much of a big deal, but as you can see from these conditions, it can be a big deal. Well, that's our video over errors in meiosis. When we come back next time, we're going to be comparing the two, mitosis and meiosis. So we'll see you then.